In this example, we want to solve the initial value problem, y double prime plus 2y prime plus 2y equals 0, with y of 0 equals 3 and y prime of 0 equals 5. So to do this, we first start with the characteristic equation, which here is r squared plus 2r plus 2 equals 0. And we look for the roots. This equation doesn't factor, so let's try the quadratic formula. R is -2 plus or minus the square root of 2 squared, which is 4, minus 4 times 1 times 2 for AC, all divided by 2. This is -2 plus or minus the square root of 4 minus 8 is minus 4 over 2, which is going to be -2 plus or minus 2i over 2, because root -4 is 2i, which is -1 plus or minus I. So from that, we can then write our general solution, realizing we only need one of those two complex roots, and splitting into the real and imaginary parts of the sine and cosine part of the function to get our general solution. We can then write that our general solution is c1 e to the minus t from the minus 1 in the real part times cosine of t from the 1 that is the imaginary part, we drop the I here, plus c2 e to the minus t times sine of t for the other independent solution. And now I want to solve for initial conditions, which means I need y and I need y prime to be able to plug in 0. Let's compute y prime. We'll need to do each term here by the product rule, which will give us a -c1 e to the minus t cosine of t minus a c1 e to the minus t sine of t. The minus on the second one comes from the derivative of cosine being negative sine. And then plus a negative c2 e to the minus t sine of t, and then plus a c2 e to the minus t cosine of t. Now, to set up our equation, we can plug in 0 to each of these that we get. Thankfully, because we have a bunch of sine terms, those will all vanish when I plug in 0, because sine of 0 is 0. When I plug in 0, I will get that y of 0, plugging into the first equation. c1 e to the 0 is 1, cosine of 0 is 1, so I get a c1. And the sine term vanishes, so I just get nothing there. And y prime of 0 is going to be, again, the sine terms go away, so I will see a negative c1 from this first term, and I will see a c2 from the last term here, because this has a cosine in it. So this minus c1 shows up, this c2 shows up, these two both go away because they are sine terms. Now, for initial conditions, I wanted that y of 0 was 3, and y prime of 0 was 5. So with this, I can solve for the constants. I know that c1 must be 3 from this equation right here. And then adding c1 to the other side tells me that c2 should be 5 plus c1, which is going to be 8. Therefore, I can write the solution to the initial value problem as y of t is c1, which was 3, e to the minus t cosine of t, plus c2, which is 8, e to the minus t sine of t. That's how you can work out and solve these initial value problems for second order equations when you have complex roots for the characteristic equation.